Okay, greetings everyone, and thanks for joining our division seminar series. Today we have Dr. Dongmin Kim, who will be speaking to us about the roles of Atlantic Nino and Nina in seasonal Atlantic tropical cyclone activity. A brief intro about Dr. Kim. He received his PhD from Ulsan Institute of Science and Technology in South Korea in 2017, and then he has been a CMOS scientist since 2018. Okay, Dongmin, you may start.
Okay, thank you. Thank you for good introduction. Hi, everybody. Thank you for coming to this seminar. Today, I will present the role of the Atlantic Nino and Nina in Atlantic tropical cyclone activity. So this study has collaborated with Sangi, Osme, and Greg, and Kai-Hong at CPC. Atlantic tropical cyclone causes severe damage to properties and human lives over the US due to heavy rainfall and storm surge and wind gust. For example, Hurricane Ida induced flooding in New York and power outage over the Louisiana and killed at least 60 people over the US. So prediction scale of the Atlantic TC is very important. So to improve the Atlantic TC forecast, previous study have discovered that a variety of the climate modes affect the Atlantic hurricane activity, such as ENSO and Atlantic meridional mode and West African monsoon and African easterly wave, and also Atlantic whirlpool variation. I will give you some example of the climate mode related to the Atlantic TC activity. So one of the major modulator of the Atlantic TC is ENSO. As shown in this figure, this color indicate the track density during the El Nino and La Nina. So during the El Nino, the warm tropical Pacific SST decreased the tropical cyclone over this North Atlantic. In contrast, during the La Nina, the cold tropical Pacific SST increased the Atlantic TC. And climate mode originated from the Africa also affect the Atlantic TC activity. For example, this wet condition over the West African monsoon region produced this favorable condition for the generating Atlantic easterly jet. So the increased African easterly jet lead to increased TC genesis over the Atlantic main developed region. So in the Atlantic, there are two dominant interannual variation. One is the Atlantic meridional mode, and the other one is the Atlantic zonal mode, as known as the Atlantic Nino. So the positive AMM, Atlantic meridional mode, is defined by this warm SST and a low-level westerly wind anomaly over the entire tropical Atlantic. So the positive AMM produced the warm SST of this Atlantic MDR, which in turn generate a more frequent and intense hurricane over the Atlantic. In contrast, negative AMM produced this colder SST anomaly over the Atlantic MDR, and it also makes a weakened pure hurricane over the Atlantic. So also the formation of the hurricane is increased over this eastern coast of the U.S. compared to this during the positive AMM. But however, this Atlantic meridional mode usually sticks in boreal spring and dissipates before the Atlantic hurricane season. And also El Nino is also typically developing phase in the Atlantic hurricane season. So the Atlantic Nino, which is the other dominant mode in the tropical Atlantic, is usually hit in the boreal summer. So this figure is a time journal evolution of the tropical Atlantic SST anomaly. The y-axis is time and x-axis is the longitude. So Atlantic Nino start to develop in May and peaks in June and dissipate in the September, end of September. So and this is in this figure, the shading is the SST anomaly and contour is SSH, and this bottom figure shows the precipitation anomaly. So during the Atlantic Nino, this warm SST over the tropical eastern Atlantic enhanced this Atlantic ITCG, which in turn produced this low level or westerly wind anomaly and upper level divergence. So this atmospheric circulation associated with the Atlantic Nino can affect the Atlantic tropical cyclone activity. So I will check some example. So this figure show the Atlantic this figure shows the SST anomaly in the shading color and direct TC track in the black line. So in 2016, as your Atlantic Nino year, so there are many TC generated over the main developed region. In contrast, in 1992, as your Atlantic Nina year, a few Atlantic TC occurred in the main developed region, and this is the number of TC over this MDR, such as marked in this red box here during the Atlantic Nino and Atlantic Nina, respectively. So as shown in this figure, during the Atlantic Nino, Atlantic TC over the MDR increased. In contrast to during the Atlantic Nino, Atlantic Nina, the Atlantic TC over the MDR decreased. So from these two example and two figures, we can assume that the Atlantic Nino and Nina has a possibility to modulate the Atlantic TC activity. Therefore, the purpose of this study is to investigate some physical mechanism for the Atlantic TC activity associated with the Atlantic Nino and Atlantic Nina. And in this study, I used the head-eye SST and ENSO reanalysis data to analyze the TC environmental condition and ENSO and Atlantic Nino and Nina. And IV track data is used to analyze Atlantic TC activity. And in the tropical Atlantic TC analysis, we exclude the tropical depression case, which is the maximum wind speed is less than 34 knots. And also Atlantic Nino and Nina is calculated by the overall less than the 1 standard deviation of the 3-month learning mean of the SST over the ATL3 region. And El Nino ENSO is also same as the Atlantic Nino, but for the Nino 3.4 region. And to explore the African easterly waves with the eddy kinetic energy. So this eddy kinetic energy is filtered by the wave number frequency, which is set to the 6 and 10 days for the period, and 10 to 40 for the wave number. It is approximately 1,000 to 4,000 kilometer wavelengths. And total period of the analysis is 1948 to 2018. And then we only focus on the hurricane season such as JJA, and we all our data and variable are detrended to avoid the influence of the anthropogenic warming. Sorry, to explore the influence of the Atlantic Nino and Nina on the Atlantic TC, we computed the Atlantic TC genesis and track density during the Atlantic Nino and Atlantic Nina. So in this figure, the shading indicates the TC genesis, and this black contour line indicates the track density, and also this red and blue contour line a positive and negative SST anomaly. So during the Atlantic Nino, Atlantic TC increased over this Caribbean Sea and the MDR, especially this eastern MDR, while the TC genesis is decreasing over the Gulf of Mexico and the eastern Florida Basin. And so this increased TC led to an increase in the chance of the landfall in the Florida, like this case. But on the other hand, during the Atlantic Nina, the TC decreased over the most of the Atlantic basin, except for this eastern Florida Basin. So as a result of this decrease in the TC genesis, TC track density also decreased over the Atlantic MDR. So why Atlantic TC is modulating by the Atlantic Nino and Nina? So to answer this question, I computed some atmospheric condition related to the TC genesis. This upper figure shows a 600 hectopascal specific humidity in shading color and low-level wind anomaly in the vector. And this middle figure shows the low-level relative vorticity in shading and vertical wind shear in this contour line. And the last bottom figure shows the 700 hectopascal eddy kinetic energy in shading color and precipitation anomaly in contours. So, during the Atlantic Nino, this enhanced Atlantic ITCG produced this low level of western wind anomaly, which in turn increased this low level relative vorticity over this eastern tropical Atlantic, and also this low level convergence and upper level divergence over the Atlantic MDR led to decrease vertical wind shear between the 850 hectopascal to and 200 hectopascal over this western tropical Pacific. And additionally, during the Atlantic Nino, this enhanced Atlantic ITCD increased the western Sahara rainfall and reinforced the 700 hectopascal African easterly wave, which is one of the key factors in generating the Atlantic TC. But on the other hand, during the Atlantic Nina, this environmental parameter for the TC genesis are nearly opposite to those during the Atlantic Nina. So there is a more decreasing low-level vorticity and increasing vertical wind shear, and decreasing the mid-level humidity over the Atlantic MDR. And also, Africa easterly wave component is negative anomaly. However, one of the important points to explore the influence of the Atlantic Nino on the Atlantic TC activity is coincidence of the ENSO and Atlantic Nino. So some previous study suggests that Hamenab and Chang et al. Suggests that ENSO and Atlantic Nino and Nina has a time lag relationship, and So, for example, this figure is the time zonal SSD anomaly of the each Atlantic Nino diversity. So, as shown in this figure, in the hurricane season, the La Nina and Atlantic Nino usually occur together constantly, except for this late onset Atlantic Nino time. So these results suggest that there is some possibility of the interactive impact between the Atlantic Nino and La Nina on the Atlantic tropical cyclone activity. So to explore the impact of the Atlantic Nino only and La Nina only, we need to isolate these two climate mode. So to isolate the ENSO and Atlantic Nino, we use the partial regression analysis. So in this figure, the shading color indicate the TC genesis, and this black contour indicate the TC track density. For the Atlantic Nino case, and this is a La Nina case, and the last one is just some of these two figures. So in bottom figure, shading is shading indicate the relative vorticity, and contour indicate the vertical wind shear. So look at this figure. So Atlantic Nino are lead to increase the TC over this eastern Atlantic MDR due to the strong positive relative vorticity over the East Atlantic MDR. And so the increased TC formed over this eastern Atlantic MDR lead to increase the travel along the Caribbean Sea and South Florida. On the other hand, this La Nina lead to decrease the vertical wind shear and increase the relative vorticity over this Atlantic wormhole region, which in turn increase the Atlantic TC and the chance of the land part along the south and southeast US. And but under both Atlantic Nino and La Nina condition, TC genesis is largely increased over the entire Atlantic MDR, and the a chance of the land part is in the US. So this atmospheric condition are largely constant with this TC genesis and track density in this upper figure. So from the results, the Atlantic Nino is gradually moderate and TC activity, especially over this eastern MDR, and also this some tendency for the La Nina to enhance the Atlantic TC activity is amplified during the Atlantic Nino and weakened during the Atlantic Nina. So to summarize, I will show you this schematic figure. So this under a La Nina condition, this Atlantic Nino enhanced this low-level westerly wind and relative vorticity over this tropical Atlantic, and also it decreased the vertical wind shear, which in turn increased the Atlantic TC activity. So it means that the Atlantic Nino intensified the La Nina and Atlantic TC relationship. But in contrast, Atlantic Nina suppressed this TC, this low-level wind shear anomaly and this low-level relative vorticity. So this Atlantic Nino suppressed this TC environmental condition over this eastern MDR. So it weakened the La Nina and Atlantic tropical cyclone relationship. To convince our hypothesis and observational-based results, we integrate the AGCM experiment, which are prescribed by the Atlantic Nino and Nina, and also both SST anomaly derived from the head-eye SST. The total integration period is 25 years for each experiment, and we analyze only the last 20 years, and all data are derived from the CESM. So this is the result. So in the model, actually tropical cyclone is not diagnostic in the model. So we only explore the TC environmental variables such as vertical wind shear and low-level relative vorticity and other things. So Atlantic this Atlantic Nino experiment show that enhanced Atlantic ITCG and westerly low-level wind, westerly low-level wind anomaly, and also relative increase the relative vorticity and decreasing the vertical wind shear. And in the running experiment, low-level westerly wind anomaly are enhanced and positive low-level relative vorticity is extended to this Gulf of Mexico, and also this negative vertical wind shear is more widespread than this Atlantic Nino case experiment. So in both Atlantic Nino and Nina condition experiment, the atmospheric condition conducive to tropical cyclone genesis are largely enhanced, such as a strong low-level westerly wind anomaly and very weak vertical wind shear and strong positive relative vorticity. So from this result, AGCM result, even though the model has some systematic bias, but AGCM experiment is well supported our observational result. And also, I will emphasize some impact of the Atlantic Nino and Nina on the major hurricane. So in this figure, the contour line is total TC genesis location for the 71 years, and shading is the total major hurricane genesis, such as category 3 to 5 for the 71 years. Shown in this figure, the Atlantic TC, just all Atlantic TC is mainly occurred over this Gulf of Mexico and the Caribbean Sea and this main developed region. Interestingly, this and this shading is the major hurricane. So interestingly, the category 3 to 5 major hurricane is generated over the mainly over the this eastern of the sixth west, such as the main developments. So because of the, I think this is because of the by more traveling pathway to provide more moisture and heat for developing the major hurricane. In the previous result, I already shown that the Atlantic Nino is closely related to the this genesis over this eastern tropical Atlantic. So Atlantic Nino can be related to this major hurricane activity over the this eastern tropical Atlantic. So this is the the time series of the 3-year monthly mean of the Atlantic 3 SST, and then a category 3 to 5 hurricane, major hurricane occurrence over the this MDR region. So this correlation between the this ATH3 SST and it is not that this is I didn't do the trend. So this is it has trend. So the correlation between the Atlantic 3 SST and category 5 hurricane occurrence over this MDR is about 0.53. So this suggests that the ATH3 SST can be a potential predictor of the major hurricane. But the one important point that, however, that if we want to use this ATH3 index to predict the Atlantic TC activity, the predictability of the ATH3 is very important. So, but unfortunately, the prediction scale of the ATH3 region in CFS V2 is very low due to some systematic bias, SST bias over the tropical Atlantic. So this is the ATH3 index prediction in the CFS version 2 initialized in August 2019. So the CFS2 paired to this evolution of the positive SST anomaly during this time. And this is the anomaly correlation coefficients of the ATH3 from the all NMME models. This blue dot line with the filled blue circle is the CFS version 2. So as shown in this period, the CFS version 2 has the lowest prediction scale, the worst prediction scale among this NMME. So actually, when we do the seasonal forecast, NOAA usually use the CFS V2 now. So these two results suggest that we need more improvement of the Atlantic Nino variability in CFS V2 version 2 using the intense observation and modeling research. And this is it. So thank you for listening. And if you have questions, please chat the chat box or just unmute and ask me.
Okay, great talk. We have a couple of questions here. First from Hyun Suk. What is the typical periodicity of the Atlantic Nino, and how does it interact with NAO?
The typical periodicity is, I think, 2 and 3 years, but I don't have an idea some interaction between the NAO and Atlantic Nino and Nina. Yeah.
But it would be possible, though, right? You know, if
Nina,
Atlantic Nino is 2 to 3 years, and then NAO say about 10 years, it might have possibly, residence year 2 as well. And then the second question, I missed the first part. What is the delta SST for Nino, Atlantic Nino?
Delta SST is some, you mean the standard deviation?
Yeah, index.
Index. So it is in the observation is 0.3. So it is 0.3 degree in my calculation. So it is relatively lower than weaker than the ENSO.
Yeah. Okay. Can you go back the slide? Let me see. Showing that the a large circulation between Eastern Pacific Atlantic.
Here,
The diagram,
diagram. Okay.
not this one. Yeah, this one, yes.
Yes, yeah, yeah.
Okay, so I wonder, you have checked the size of a subtropical gyre in Atlantic for case A versus B?
No, I didn't do that.
You mean can you click on one more time?
Yeah.
And one more time. Yes, here you go.
This is particular wind. So this is okay. How can I say, this is the work circulation.
Oh, the walkers. Yes.
Yeah.
Okay. So if it is, then they might have also different size for the subtropical gyre.
Yeah. So
High pressure system.
Case.
So I was wondering, this the western flank of the subtropical high system has to do with the large population of tracks and the solid contours.
Yeah.
All right, so you haven't done it. Okay. All right, thank you. Good talk.
Yeah. Thank you very much. And Marlos, so this SST is detrend. No, in this slide, the SST didn't do the detrend, but except for this slide, all of this anomaly and the variable is detrending. Yeah, just only for the this SST is just using the detrend SST. And
Stanley, go ahead.
Yeah, Stan, could you give me some comments?
Okay, I have to unmute here. Thank you. So very, very interesting. Can't possibly absorb it all. So I'm going to look over it. Maybe you can send me the slides and I'll look over it, discuss it with you. But I was really thrilled you did some partial correlations, partial regressions. When you started to talk, that's immediately what I was going to comment on, and you went and did that. I think that's what we did in our 96 paper, which is a fantastic, simple, but powerful tool. One comment on graphics, it really helps to put in the boundaries of the MDR on all the slides, because that way it draws people attention immediately to that key area. Can you go back to the slides where you had the tropical cyclone activity and you had solid dots and pluses? Solid dots and pluses, it was earlier. There, no, you passed it.
This one?
You passed it, you did it. It had the solid, there, that one. What were the solid dots? Because it wasn't in the legend. What were the solid dots and what were the pluses?
So plus is just tropical storm, but this very big circle is the tropical hurricane. I think, yeah, I remember that.
Major hurricanes?
Yeah, major hurricane. I remember.
Okay, that's where they formed, or that's where it became a major hurricane, or that's where they began genesis?
Oh, I forgot. I forgot. But
okay, we can talk about it later. The other thing, I've said this to various people. When you include, this is my suggestion, when you include too long of a temporal time period for the Atlantic, you really blur the results. I strongly recommend focusing in strictly on August, September, October. That's when the vast majority of the activity happens, and that's when the season really cares what's going on. The other stuff is almost noise. So by adding, did you do June, July ASO? What months did you do?
In my case, JJASON.
SON, right. I strongly recommend that. You'll find the results are more clear. And when you just do that area, and also you can zero on activity in certain areas. But this is very, very interesting stuff that I'd love to look on more. The other thing I would say is because of certain parameters, when I did the study with Golomir Shapiro, we could only go through 93 or 94. Now we can go all the way to 2020, 2019, and I would resist using the 40s and the 50s and maybe even the 60s, because the analysis of sea surface temperatures, the atmosphere, even the storms to the east are not going to be near as good. And you just find different results when you kind of zero in on the more reliable data areas. But thank you for your talk, and thank you for letting me make a few comments.
Okay, thank you for good suggestion. Yeah, we can discuss more, and I will give you my slide. And we have other question. So have you looked at the stratified by the seasonality? So yeah, TC and category 3 to 5 tropical storm genesis become more frequent in the Western Atlantic and Caribbean and Gulf of Mexico later in season. So it's totally true. Yeah, but I checked the seasonality of this, but in the late season, the El Nino ENSO signal is more dominant than the Atlantic Nino. So Atlantic Nino is not much moderate the moderate TC anomaly in the late season. So I just calculate this whole season, whole hurricane season, JJASON. Yeah. So he also mentioned that to small sample size. So I try to convince our hypothesis and observational based result. I did the AGCM simulation with a prescribed SST like this one. So the model has some systematic bias, but the overall the result AGCM result is supporting our hypothesis and observational based observational result. And show me on page 30, you show La Nina and on page 30, you show the La Nina and Atlantic Nina. So how many cases? Oh yeah, this is a great question. Actually, it has in the observation, it has 3 years. Yeah, there are a few cases, but in this A case, under the Atlantic Nina and Atlantic Nino, there has over the 12 case, 12 years. Yeah, in this bottom figure, there a few cases appeared in historical record. Yeah. Actually, the Atlantic Nino is induced this La Nina case, and also La Nina also induced this Atlantic Nino. So this is easy to appear, but in this Atlantic Nino and Atlantic Nina, La Nina and Atlantic Nina case is very rarely occur. Yeah. I just calculated this on. So I did a lot of things. Yeah, but the in page of the both two slides is very short, very rare case. So I did this modeling study, modeling experiment, sensitivity experiments. So. Any other questions?
Still have plenty of time left.
And I think this study is a great kick-off study to collaborate with this HID and PhD. So we are okay. We are now moved to the our research is try to move to the focusing on the hurricane forecast or related study.
So Dongmin Liu has some comments. Maybe you want to comment on?
Okay. Yeah, this is great suggestion. Yeah, I'll check it. Yeah, but in my case, just based on the location of the genesis location of the particular city or time. So you mean the I can compare this one and the location, the intensification to the particular city or time. Yeah, that is also good and interesting comment and idea. I will do that. I'll check that. Thank you very much.
Okay, great. I think we should stop here then. Thank you all. See you next time.
Okay, thank you very much.